Hey math kids, on this assignment we have to use a couple formulas that you probably haven't used for a while. And so I wanted to just do a quick review on those. So first we have the distance formula, and I just wanted to remind you that probably when you first learned about this, you, you learned that it was basically just the Pythagorean theorem. So what we use the formula for is if we're given 2 points and we know their coordinates, then we find the distance between those 2 points, or the length of a line segment that connects those 2 points. And the way that the formula is derived is actually we draw a right triangle. And so if we call this x1, comma y1, we call this point x2, comma y2, that would make this point, it's sharing the same y value, so it's y1, and it's sharing the same x value as this, so it's x2. So if we wanted to name, let's see, I'm going to change the color maybe to this. So if I wanted to name this side, what it's going to be is x2 minus x1. That's how we would find the length of just that side. And then this blue vertical side is going to be the difference between y2 and y1. And so, that's what we have. Now we call this d in the formula. It's just our distance. And if we remember the Pythagorean theorem, which is a squared plus b squared equals c squared, our a is just going to be this pink one. So it's just x2 minus x1 squared. Our b is going to be y2 minus y1 squared. And then our hypotenuse, or our c, is labeled as d. And we can already see that this is looking very close to the distance formula that we have over there. Just to solve for d, we take the square root of both sides. And that leaves us with d is the square root of the quantity x2 minus x1 squared plus the quantity y2 minus y1 squared, and that's our distance formula. So it looks a little more complicated than the Pythagorean theorem, but that's really just the heart of it. That's what we have. Okay, now the midpoint formula, really, the way that I like to think about it is it's just an average. So once again, we have a line segment. We want to know, and we know the coordinates. We know x2, or not x2, x1, comma y1, x2, comma y2, and we want to know the point that is exactly in the middle. And we have a formula for finding that, but really all it is we're just adding the x's together and then dividing by the number of x's that we added. So it's really just an average of the x's, and then we add the y's together and then take the average. So it's really just the average of the x's and the average of the y's. And this is the midpoint and the midpoint formula. Okay, now the next formula on the list is our circle formula. We've used this pretty recently. We've used it in this unit, actually, so you probably remember this one, but just in case you don't, I just wanted to remind you. Okay, so r is the radius of a circle. H comma k is the center. And a couple things to keep in mind. If we see a number, so if we have x, something like this, the number we see here is the radius squared. And so when we pull out the radius, we have to take the square root of that number, and so the radius is only 5. When we're talking about the center, we want to change the signs that we see, because in the original formula, they're both minus. That means negative. That means we need to change the signs. So we see -3 here, So the x value of the center is positive 3. We see a positive here, so we make it negative down here. Okay. Now we're going to talk about the slope. So once again, slope describes how steep a line is. Probably the first way you encountered it is we see the difference in how our height changes, and then the difference in how our left to right, the horizontal, changes, and we often just say this is our rise, how much we change there, and then this is our run. So we might count up 2 over 3, and so that would be a slope of 2/3. Now, if we get a little bit more technical, we can say the change in y, the change in x. That's still kind of represented by rise and run, but the formula that we tend to use is, once again, if this is x1, y1, and this is x2, y2, we're just asking about the difference in the y's, so y2 minus y1, and then the difference in the x's, which is going to be x2 minus x1. And that's our slope formula right there. And then the last thing I wanted to remind you about is if we have a slope of a line, and let's just say this one is m equals 7/3. Okay, so the slope of that line is 7/3. If we want to find a perpendicular line to that, once again, perpendicular means makes a 90-degree angle with that line. I guess technically these are segments, but works the same way. So if we know the slope of the orange line, and if we know that the red line is perpendicular, we actually can find the slope just using this text. So it says if the slope of line is a over b, then the slope of the line perpendicular to the original line is negative b over a. This is called the opposite reciprocal. Notice how the sign changes and the fraction flips upside down. So opposite in math means change the sign. This is positive, so this needs to be negative. Reciprocal, when talking about fractions, just means you flip the fraction upside down. So the 3 goes on top and the 7 goes on bottom. So once again, change the sign, flip the fraction. Okay, let's try just one more. Okay, I'm going to say this is negative 3/2 for the slope. Then if we have a perpendicular line, or a segment, then the slope of the yellow one is going to be, this one is negative, so this one's positive. And then we flip the fraction upside down, which is called the reciprocal. And once again, opposite reciprocal. Notice how both of them have different signs. Both of these have different signs. Notice how the 3's on top, 2's on bottom. We flip that upside down, 2 on top, 3 on bottom, 7 on top, 3 on bottom, 3 on top, 7 on bottom. So you change the sign, flip the fraction. If you need additional help with this, please come to Math Lab. Until then, calculator.